Okay, so this is 3-4 differentiating inverse trig functions. Now on these, we have to do some memorization here, and to help you remember, I want you to remember that if it has the co with it, that it is complementary. Like sine and cosine, secant and cosecant, tangent and cotangent, because that's going to help us remember groups of them, hopefully. Also, if it has, well, let's see, if it has an S, if it's starting with an S here, then you'll see that it has subtraction in it and square root. Also, if it starts with a C, it has the negative. It's negative. Okay, so let's see the first one, the derivative of the inverse sine. We got the S, so we know it has the square root. This is 1 over the square root of 1 minus x squared. The cosecant of it, the complementary one, cosine, the derivative of cosine, would be the same thing, only negative. So this one starts with a C, so it's negative. And notice sine and cosine are almost the same thing. It's just a different sign. Secant, the derivative of the inverse secant, is 1 over the absolute value of x, square root of x squared minus 1. So I know that looks really crazy. Lots to remember. The cosecant one is the same thing, only negative. So they both have subtraction in it. These have the square root. You look whether it has the C or the S. Sometimes that helps to remember. As far as the tangent one goes, this is 1 over x squared plus 1. And the cotangent, again, has the C, same thing, just negative. So really, if you learn the three of them, like this first column, then you already automatically know the cos, because it's the same thing. All right, so let's start using these. And I know it's going to take some while for you to memorize it, but the more you use it, the better you're going to get at it. But you're just going to have to know these. Okay, so number 1, find the derivative of the inverse tangent of 3x. So just flat out using our formula, remembering our chain rule and everything too, this would be 1 over the square root of 1 minus 3x squared is 9x squared. And then we got to multiply it by the derivative of the inside, so it's times 3. So let's see if we can write it more compactly. Kind of need a little bit more room on here. 1 minus 9x squared. Okay, so this is our answer. Okay, so for tangent, let's see the tangent functions up here. Again, you've got to worry about the chain rule because there's a function on that inside piece. So we have 1 over, I'll just write the steps, 2x squared squared plus 1 times the derivative of that, which would be 4x. So our answer would be 4x over 4x to the 4th plus 1. Then the next one, remember if you have the arc secant, it's the same thing as the one with the negative 1. It's just another notation for it. Let's see, that one would be 1 over the absolute value of 5x times the square root of 5x squared, so that's 25x squared minus 1. And then we've got to multiply it by the, with the chain rule, the derivative of this piece, so that would be 5. The 5's would cancel out. the monomial in the front and the monomial at the back there. So this would give me absolute value of x times the square root of 25x squared minus 1 is my answer. Okay, so let's look at the next little part, simplifying the following expressions. Now, the thing here, you see how some of them have the square root on the problem. The answer may or may not have an absolute value. So we have to figure out, do you need an absolute value? Sometimes. So I'm going to write that here. Sometimes you need an absolute value. But not always, okay? So it kind of depends when we simplify them. So let's look at those. If I'm given this one, I want you to simplify like you normally would, okay? And then we'll deal with the absolute value symbol after, okay? So if we normally would simplify this part on the top, this piece would simplify with this piece, right? So that's what we're going to do. So if we simplify that, we're going to end up with a 3 on the top, an x there, and then I'm going to bring everything else down because I can't simplify this one because it's under the radical. Now let's determine, do we need the absolute value or not? Okay, so here's how you're going to find out. You are going to let x be -1. It's a negative number. It's one of the easiest ones to do. And look at your original problem and see, would it be positive or would it be negative? So if I put in a -1 on the top, I'm going to have a positive number on the top. I would also have a positive on the bottom. That means I'm going, that would be a positive. So that means I need all of my solutions to be positive. And if they're all positive, then that means to make sure this one is all positive, you know what, let me just go to a different color because I want to highlight it. I know it has to have an absolute value there. Because if I put a -1 in my answer, it's not going to give me a positive unless I have that absolute value there. So that is how you figure out, do you need it or not? All right, so let's look at the second example. If we look here, we're going to cancel this piece with this piece. All right, so this would be 2 on the top, an x here, and of course we've got all this on the square root. That doesn't change because I can't cancel with that because nothing else is in a square root. Now we got to determine, do we need this square root or not? So I'm going to go over here to the side, and if I put in, I'm going to let x be -1. This is how I'm testing. If I put in a negative on the top, I get a negative answer. If I put a negative on the bottom, I'm going to get positive, which means I could have a negative. So since this can be a negative, then I don't need the absolute value on the bottom one. Okay, so on this part, domain of an inverse trig function. If you remember back from pre-cal honors, the domain of an inverse function is, well, it's shown here. If we have the inverse of sine, remember the domain and range flip based on the regular function. Like if the inverse sine, the domain and range is opposite than that of the regular sine. So here, if our range is going from -π/2 to π/2, the domain of the inverse function would be that. So for sine, remember sine is only in these two quadrants. And cosine was from 0 to pi. So in these two quadrants was cosine's domain, the inverse cosine's domain, I should say. Tangent is from there to there in quadrants 1 and 3 again. But remember, tangent did not include the endpoints. Okay, these were like open circles because you see how it does not have the or equal to. So the range of the original function is now the domain of its inverse, and that's very, very important. So you need to make sure you remember that from pre-calculus. Okay, so on the last few examples we have here, we're going to evaluate each function at the given x value. So if the function is the inverse sine of x at x equal square root of 3 over 2, so this means we have the inverse sine of square root of 3 over 2. So let's see, what does that mean? That means we're trying to figure out what is theta. Because remember, that means that sine of theta is equal to square root of 3 over 2. That's what that inverse function means, the inverse sine means. So think of the unit circle. If you still have yours, you might want to look at it to get familiar with it. What angle measure is going to give me a sine of square root of 3 over 2 that's in the domain of the arc sine? You're right, it is pi over 3. Because remember, you're thinking of your y value of pi over 3 would be square root of 3 over 2. On number 7, cosine, the inverse cosine of x over 4 at x equal negative 2. Well, if I plug that in, this gives me the inverse cosine of negative 2x over 4. And if I simplify that, that would be, I guess I need to take the x out, because that x should not be there, negative 2 over 4. So this would be negative 1/2. Okay, so basically, I am asking myself, if we have cosine of theta equal to negative 1/2, what is theta? So if you're using unit circle, but remember, you got to restrict the domain to only quadrants 1 and 2 for this one. This would be 2 pi over 3. So we're getting to where the trig stuff's coming in. You need to know that unit circle, so make friends with that unit circle. Then number 8, the arctan of 1 over square root of 3. So this means that we have the tangent of some angle is equal to 1 over square root of 3. Well, if you remember, tangent is sine over cosine, and if you're using unit circle, you know that it has to be 1/2, and this would have to be square root of 3 over 2. It's the only points that actually would work and make that be 1 over square root of 3. So using unit circle, we know that is pi over 6. Okay, so I want you to work the rest of these on the practice. I will post the answers only, and we'll talk about 3.3 and 3.4 tomorrow in class.